In today's video, we're going to be talking about the mathematics of lenses. So if we take a look back at lessons 6 and 7, those lessons involve drawing ray diagrams for converging and diverging lenses. Those drawings, while wonderful, give you no mathematical value behind the pictures that you draw. So you have no idea how tall the object is, or how tall the image is, I should say, or how magnified or shrunk the image is, or if it's where it is, how far away it is from the lens. All those are things that you can kind of get a perspective of it by your picture, but you can't say for certain how many, say, centimeters it is away from a lens. And so today's lesson is going to be talking about how we can actually get some mathematical numbers associated with those ray diagram drawings that you were doing in the previous lessons. So after watching this video, you should be able to use the lens equation and the magnification equation. And quite frankly, these are the same equations that we were talking about in the previous chapter. I'm going to try to fly through this pretty quickly, but I'm going to do some example problems with you guys using these equations. All right, so the lens equation is basically this, where you have 1 over the focal length equals 1 over d sub o, which stands for distance to the object, plus 1 over d sub I, which is distance to the image. And that is the lens equation, and like I said, it's the same equation that we looked at in the previous chapter. Okay. The second equation is the magnification equation, and this big M stands for the magnification, how many times bigger or how many times smaller will the object be, or the image I should say, be than the object, okay? So if you have a whole number there, say like 4 for instance, that means that the image is going to appear 4 times bigger than the actual size of the object, okay? And that magnification equals the height of the image, which is h sub I, over the height of the object, or h sub O. And that also is actually equal to the distance the image is from, or d sub I, from the lens, divided by the distance the object is from the lens. And there's a negative sign here, and remember the signs are typically going to be telling you whether or not it is going to be producing a real or virtual image in this case. Where in the distance piece, if it's negative, it's going to be a virtual image, and if it's positive, it's going to be a real image. Okay. So those are the two equations that we're basically going to be using. Let's go take a look at some example problems, shall we? It says an object is located 0.15 meters from a converging lens with a focal length of 0.1 meters. How far from the lens is the image formed? So first thing I would recommend doing is drawing a picture of this problem. It doesn't have to be a beautiful picture, but I think it's a good idea just to kind of get a visual image of what's going on here. So the focal length, and there's 2 of them, but the focal length is going to be, let's see here, 0.1 meters, 0.1 meters. And there's an object, which I'm going to represent by an arrow. This object, and I'm going to represent the distance of the object, or d sub O, is 0.15 meters away from the lens. Okay? And the question is, how far away will the image be produced from this lens? Okay, where will the image form, and how far away is it? So that is what's called d sub I, right? That's what I want to know. So how will I solve for that? Well, I'm going to use something called the lens equation, which is 1 over f is equal to 1 over d sub O plus 1 over d sub I. And basically what I'm going to be doing is I'm just going to plug numbers in. Okay, so 1 over f is 1 over 0.1 meters plus 1 over the d sub O is 0.15 meters. I'm sorry, this is equals, my fault. So 1 over 0.1 equals 1 over 0.15 meters plus 1 over d sub I. I'm really sorry about that. Okay, so you get this equation all set up, and basically all I do is I just plug numbers into the lens equation. I want to find out what d sub I is, and if you go through the algebra and get d sub I all by itself, you would find out that d sub I equals 0.3 meters. And let's just take a moment to think about what does that mean. Basically, this object is 0.15 meters away from this lens. The image that's produced will appear to be 0.3 meters away from the lens. Okay. All right, let's do another problem. It says a converging lens forms a real image that is 4 times larger than the object. If the image is located 0.16 meters from the lens, what is the object distance? Okay, so again, I recommend drawing a picture just to get kind of a visual on what's happening here. Converging lens, all right, and it says that a real image that is 4 times larger than the object. Okay, what that is telling me is that we're going to be probably using this thing called the magnification equation, all right, and the magnification equation basically says m equals hi over ho, which also then equals negative di over do. Okay, and so a lot of times you're going to just use either m equals hi over ho or m equals di over do, or you could have hi over ho equals di over do. I know it's a lot, but basically you're going to pick a set with another set to work with. You won't use all of this at once. Okay, and in this situation, it looks like we're going to be using, if the image is located 0.16 meters from the lens, it looks like we're going to be using this guy right here along with this m, because what they're saying is that this image is 4 times larger, okay, and that is my m. So my m is going to be 4 times larger. So I'm going to put 4 there. M equals 4, all right? And the image is located 0.16 meters from the lens. So I'm going to write it right here, make a little arrow. That's my image. So that is my d sub I would equal 0.16 meters, okay? So basically, the equation that what I'm trying to find out is d sub o. Okay, what is d sub o? And so the equation that I am going to use, and I'm going to simplify this up here, m equals d sub I over d sub o. And you'll notice I dropped the negative, okay? And that negative is solely there just basically to tell you that if this turns out to be negative, it will be forming a what's called virtual image, okay, a virtual image. But right in the problem, it says that it's forming a real image. And so real images are positive, and I can just drop that negative sign straight away, okay? That there's no issue with having to keep it, okay? So what I'm going to do is I'm going to plug numbers in, all right, and my m is 4, so I have 4 equals a d sub I of 0.16 meters over d sub o. Okay. And basically, if you do the algebra, you will find out that the d sub o, or the distance to the object, equals 0.04 meters. Okay, and that would be my answer. All right, so previous example problem, I was using the lens equation. In this problem, I used the magnification equation. In the last problem, this one's a little bit more intense. We're going to be using both equations. It's very exciting. It says determine the image distance and image height for a 4 centimeter tall object placed 54 centimeters from a converging lens having a focal length of 18 centimeters. Okay, I'm going to draw a real tiny picture up here because there's going to be a lot of stuff going on in this problem. Okay, so it's a converging lens. Okay, so it looks something like this. And we have a object, which I'm going to represent with an arrow, that has two things that we know about it. It has a height, or an HO, of 4 centimeters. And right away, a flag goes up in my head that this is in centimeters. For lens problems, as long as everything is in centimeters, you can use centimeters. But let's say one of these numbers was in meters, you would then want to also convert that to centimeters so everything's the same. So the point is you can't compare apples and oranges, as the old saying goes. You need to compare apples to apples. So if you have everything in centimeters, that's cool. The lens equation works just fine and dandy in centimeters. And my other two previous example problems, everything was in meters, and that's cool because everything was in meters. So you just make sure you have all the same units. So I'm going to stay in centimeters for this problem just to kind of show you that it does actually work. Okay, so the height of the object is 4 centimeters, and it is placed 54 centimeters from a converging lens. And so my d sub o is 54 centimeters. Okay, and this lens has a focal length a focal length, and there's two of them, so focal length of 18 centimeters. Okay, so this is what I know. Okay, I want to know the image distance and the image height. Okay, so I'm wondering what in the world is d sub I, and I'm wondering what h sub I is. Okay, those are my two questions. To get d sub I, I'm thinking I can just use the good old day lens equation, which is 1 over f equals 1 over d sub O plus 1 over d sub I. And basically, if I plug some numbers into this bad boy, the focal length is 18 centimeters. I'm going to have 1 over 18 centimeters equals 1 over d sub O, which is 54 centimeters, plus 1 over d sub I. And if you do the algebra there, you would find out that d sub I would equal 27 centimeters. Okay? Well, that's nice. That answers one of my questions. The second question, though, is what is the image height? Okay, and I'm going to use the magnification equation, which basically says m, that's a real crummy looking m, I'm trying to make it worse, but m equals hi over ho, which is also equal to negative d sub I over d sub O. Okay. I don't really care about the m right now. I mean, we could certainly find out the magnification, but that's not something the problem's asking me, so I'm looking for just this piece right here. Okay, so I'm going to be using this part of the equation right there. Do I know h sub I? I don't. That's one thing I'm trying to find here. So I have h sub I over h sub O, which I do know, it's 4 centimeters, is equal to negative d sub I, which at the beginning of the problem I did not know, but I solved that here, right? So I know that it's now 27 centimeters. And d sub O I was given to in the problem, that was 54 centimeters, so I'm going to write that right there. And if you basically cross multiply and then divide, you would get an h sub I of negative 2 centimeters. And that would be the answer. Now let's take a quick second to talk about what those numbers actually mean. The height of the object is 4 centimeters, but using this lens, it is going to produce an image of 2 centimeters tall. So it's going to appear smaller. It's going to be shrunk. This negative here on this 2 basically means that that image is inverted, meaning it's upside down. It's not right side up anymore. Now it's appearing upside down. So that takes care of today's video. I will see you guys next time.